2x plus 6 over x minus 1. So we're asked to graph this function showing everything. Asymptotes, x and y-intercepts, etc., etc., etc. So the first thing I'm going to do, of course, I'm going to factor out 2 at the top. I know it's a rational function and it's type 1 with same degree over same degree. I know that the domain of this function is anything but 1. I know that x equals 1 will be a vertical asymptote. And I know that these sides will be infinities. What I don't know is the sign of those infinities. For the signs, I will plug in 0.9 and 1.1. So when I plug in 0.9, this is positive, but this is negative. And when I plug in 1.1, everything is positive. Next, for the end behavior, because it's type 1, is the leading coefficient over the leading coefficient, which happens to be a horizontal asymptote. I will plug in 0. When I plug in 0, these two terms go away, and I have 6 over negative 1. So that's negative 6. And I will set f of x equal to 0. And only the numerator can be 0. So I get x plus 3 equals 0, or x equals negative 3. And the last thing that does not fit in the table is the symmetry. And I will write that f of negative x does not equal f of x, and it does not equal negative f of x, meaning not symmetric. So now I'm trying to make sense of this information, and it's very clear from 2 to 0 to negative 6 to negative infinity, from positive infinity down to 2. It makes sense. No max min, no multiplicities. So I'm going to graph. I have to graph the asymptotes first, and there are 2 asymptotes. X equals 1 and y equals 2. And then I just plot the negative 3, 0, and the 0, negative 6. And I graph what I see. And this is the function 2x plus 3 over x minus 1. Any questions on this? Next question, please. Anything else that you would like to go back to from any test, any topic, anything?
Are we able to see all the test solutions on this? Like from at home or on Canvas?
Sorry?
Like the test solutions, I just click on it. Are we all able to see that?
Okay, here's a folder entitled Tests and Solutions. Test version 1, test 1 version 1, and solutions. Version 1, version 2, test 1, version 2, and solutions. Test 2 is it's open.
So we can all see it?
So you haven't seen this in 3 months?
No.
What can I say? It's right here. You have to, maybe you didn't see it because you have to open it. You have to open it and you'll see everything. After each test, I said I posted solutions. I posted the test. Please review the test every weekend. We remember that?
Yeah.
Good. Good. Okay, next question, please. Anything you'd like to go back to? Any type of problem, anything? Any questions? Anything you'd like to work on? Anything? Is everything clear? Is it? That's awesome. That's awesome. I'll do anything. Yes. Yes, Lani, go ahead. On test 3, number 8. Very good. Let's take a look. Number 8 on test 3. Yes? What do you think is the issue here? We had this problem last time. Yeah, but that's okay. No, let's go. We can go over it again. Yes. So last time we worked on this particular one, and the previous time before the test we worked on a similar one. So I recommend stating restrictions because you may forget. You may forget to go back and check the answer in the original problem. So once you state the restrictions and you see that the common domain is greater than 1, then you condense the left-hand side, and it's a ratio. And at this point, you say the left-hand side equals the right-hand side. They have the same log, the same base. Then these two have to be the same. And you set them equal to each other. You cross-multiply because now this is a proportion. You cross-multiply, and you get this. However, one of the solutions works, and the other one doesn't. Because 3 is greater than 1, but -1 is not greater than 1. Now, in the previous class, when we reviewed, we looked at another problem similar to this. It was right here. Because we reviewed really everything. Sorry, I'm lying. And I don't want to. It's not my intention. It was the previous time. It was not the 27, it was the previous. It was this one. This one. So here we had the same situation, log plus log equals log. And then we stated the domain. The common domain was a to infinity. And then we condensed the left-hand side, changing it into a product. log applied to a product. So we got this. So the same situation now, it's just that I don't have a ratio equals another ratio, but I have a product equals x minus 8. And then the left-hand side, we FOIL. The right-hand side is x minus 8. And then we move everything to one side, set equal to 0 because it's quadratic. And we got that x equals 2, the only solution. However, the common domain said 8 to infinity. Since I got x equals 2, I'll say, sorry, it's not working. And since it's the only solution, the equation has no solutions. Is that okay? Good. Any other topic? Very good topic to raise. If you have any problem for me that you came across my math lab, or any problem that you would like to look at, or if you would like me to choose a problem from a particular topic or whatever. As I said, today is your day. You dictate. I'll comply. Which test should we go back to? Okay, maybe I should dictate some topics. Maybe you will choose from the topics I dictate. Let's write them down. Rational equations. We already looked at a few examples. That's one, rational equations. Radical equations. Quadratic equations. Absolute value equations. That's one topic. Under inequalities, linear inequalities, compound inequalities, absolute value inequality, rational inequality. Next topic, simplify the difference quotient. Next topic, piecewise defined functions. Determining a function that is linear, given 2 points. Find the function. Reading from a graph, like domain and range, max, min. Reading from a graph. Graphing a polynomial or rational, not both. Graphing a polynomial or a rational function. Decomposing a function, the inner and outer. Decompose a function using the inner and the outer. Finding the max min of a quadratic function. Identify the equation of a circle. Log equation, exponential equation. Of course, our favorite Gauss-Jordan. I see someone is laughing and smiling. Okay. Nonlinear systems of equations and inequalities. And then few questions with sequences. And a word problem from exponential and log with a bacteria or some growth model or radioactive decay model. And that's it, 20 questions total. What would you like to go back to? What topic? Say it again?
Piecewise functions.
Right, we did that last time. You want to do another? Okay, let's make one up. Let's make one up. Okay, very good topic, of course. Okay, can anyone give us two functions? We know so many functions now. We know rational, we know quadratic, we know absolute value, we know radical, we know log, we know exponential. We know so many functions. Too many. The numbers should not be that big because we're not going to be able to. You said 2x. Okay. What about the second one? Or we can have 3, but at least the second one. You want x squared. That's it? Minus 1. Okay, x squared minus 1. So let's say if x is less than or equal to 0, let's say if x is greater than 0. Excellent. Good pick. Obviously, this is negative infinity to 0. Obviously, this is 0 to infinity. And what is the domain of the entire function? Of course, of f of x. Say it again. Yes, of course, there are no gaps. Very good. Awesome. So I know it's negative infinity to infinity, and I know that the key point is 0. The left-hand side includes a bracket under 0, and the right-hand side has a parenthesis. On the first piece, we have 2x plus 3, and on the second piece, we have x squared minus 1. So let's see how we graph 2x plus 3. Of course, we have to plug in some numbers. You can plug in 3 between negative infinity and 0. Yes, negative 3 is good. So negative 3 times 2 is negative 6 plus 3 will be negative 3. But I also want to plug in negative 1.5 because negative 1.5 will give us 0, which is the x-intercept. When I plug in 0, I get 3. And that 3 has to be inside the bracket. On the other side, when I plug in 0, I get negative 1. And of course, when I plug in 1, 1 is a key point because it's another x-intercept on the other side of 0. So now let's graph this. Negative 3, negative 3. Negative 1.5, 0. And 0, 3. Full point. You cannot extend this graph to the right. And now on the other side, I have 0, negative 1, which has to be an open point. And I have 1, comma 0. And I know how to graph x squared minus 1. It's a quadratic. And that is the graph. Very good pick. It was a collective, contributive effort. Good. That's awesome. From the list of topics, what do we do next? Look at the list of topics and say, name one.
Can we do one problem with like factorial expression and then another one with like a summation notation?
So what was the first one again?
Factorial expression.
Yes, of course. Let's look at factorial first. So you wanted a numerical one or non-numerical? Okay, let's do both. So let's say n plus 3 factorial divided by n minus 1 factorial. In order to simplify this, I have to ask myself which one is bigger. And the answer is the top is bigger. N is a natural number. So then I start with n plus 3, and then n plus 2, and then n plus 1, then n, and then n minus 1 factorial. And why I stop at n minus 1 factorial? Because the denominator is n minus 1 factorial. And then I simplify. You do not have to multiply or distribute this or expand. Just write it as n, n plus 1, n plus 2, n plus 3. That's good enough. So that was a non-numerical. In other words, it had a variable in it. But now let's take a look at a numerical one. So for example, let's say 20 factorial divided by 23 factorial, or yeah, 23 factorial. Which one is bigger? Well, obviously the denominator this time is bigger, so I have 23 times 22 times 21 times 20 factorial, so I can simplify. And yes, I will have to use a calculator on this. 21 times 22 times 23. If you do not put parentheses around the denominator, you will not get the correct answer. So let's put it in the graphing calculator and see what we get. So, did we get it? So that's 1 divided by 21 times 22 times 23. And I got 9.41 times 10 to negative 5. It was expected to be a small number. 9.41 times 10 to the negative 5. So this is how we handle the factorials. What was the second? The summation notation, very good. Any particular type of summation notation you want just to evaluate it, or change the sum into a condensed with a calculator, you mean? Okay, so here's an example. Let's say from I equals 3 to 10, from 2I plus 4 over I squared minus 3. I have no idea what to expect on this. So let's take a look. If you do not have a calculator that allows you to calculate the sum, then you can use the software on the computer. So, okay, oh, I didn't mean that, of course. So I go to math, scroll up to summation notation, and then we have from x equals 3 till I picked, what did I pick, 10. And then careful with these parentheses. You have to have parentheses around the numerator. 2x plus 4. Close the parenthesis, divide by, in parentheses again, x squared minus 3. Don't forget to close the parentheses. And then press enter. And the answer is 4.9596, approximately, of course. Is this okay? Is that what we had in mind?
And then, isn't there another a way to do summation too?
And
Like,
not,
it's like the two, like they use like two, like on test 3, like 16.
let's take a look. You said test 3, 16. Let's take a look. So yeah, so this is, I did this. So that's why I was asking, do you want an example to
Yeah.
condense? So what we did was from here, right now.
Oh.
This is what we did, from here, here. So you want now from a sum of terms into a condensed sum with using the summation notation. Okay, very good. So let's do that. So let's say we have 1/2 plus 1/3 plus 1/4 plus ... plus 1/20. We want to condense this. How do we condense it? We have to find it. First of all, we have to write the summation notation, right? And we have to have a lower limit, we have to have an upper limit, and then expression with I or K, whatever index you would like to use. Okay, so from K equals what? Say it again. Okay, you can use 1, you can use something else, but let's use 1. Let's see what happens. The index cannot be anything else but 1, 2, 3, 4, 5. It's the number of the term.
Okay, so what would be the other one? 2?
Yeah.
Okay.
So K can start at 0, could, or 1, or 2, but it cannot have 1.5, it cannot be 0.5, it cannot be 3.9, because there is no term 3.9.
Okay.
The first term is term 1, or it can be term 0. I can have term 2, term 3, but I cannot have term 0.5. There is no term with the number 0.5. It's a very good question, actually. I don't know if I expressed that like that. So yeah, so it's a very good question. With your questions, you're helping me as well. Good. So to what number? Well, it depends on what we put here. So we can do that, but it depends on what it has to work. So what do we put here? They're all fractions. So obviously every one has to be a fraction. 1 over. If I put K, I will not be able to determine to get the first term. Because when K is 1, I get 1, and that's not what I have. Say it again.
I said right.
So then we have to make some adjustment. So so that I can get the first term. In this case, I don't get the first term. So I have to make some changes. Say it again.
1 over 2k.
Say it again. 1 over. Any suggestions? Yes, Alison? Okay, we can make that change, or we can put k plus 1. Excellent. So when k is 2, I have 1/2. When k is 3, I have 1/3. When k is 4, I have 1/4. When k is 20, I have 1 over 20. So now, indeed, we'll have to stop at 20. If we had k plus 1, we would have started at 1, and we would have ended with 19. Same thing. So I can say or k equals 1 through 19 over 1 over k plus 1. One or the other. Both will give us the same answer. Next question, please.